Hey everyone, I'm Said and welcome back to the channel. Today we're gonna solve two more very important examples of upper and lower Riemann sums. So make sure to stay with me until the end of the video. And if you enjoyed this kind of content, please subscribe to our channel and don't forget to hit that like button. So let's go. Wow, look at this one. This is such a neat example because it involves an absolute value. The question is find the area under the curve for the function y equals the absolute value of x squared minus 4 on the interval 0 to 4 using the lower Riemann sum approximation with n equals 4 subintervals. First, find the width of each subinterval means delta x equals 4 minus 0 over n. N is 4. So we have 1. So our subintervals are 0 to 1, 1 to 2, 2 to 3, and 3 to 4, right? And before we find the lower sum, let's see how the function behaves. Inside the absolute value means x squared minus 4 is 0 at x equals 2 and x equals negative 2, but negative 2 is not in this interval, so we have only x equals 2. So between 0 and 2, x squared minus 4 is negative. So the function is 4 minus x squared. It's decreasing here. And between 2 and 4, x squared minus 4 is positive. So the function is y equals x squared minus 4. It's increasing, right? So we have y equals 4 minus x squared if x is between 0 and 2, and x squared minus 4 if x is between 2 and 4. Since we are looking for the lower sum, we need the minimum value of the function is in each interval. So first interval means 0 to 1. The function is 4 minus x squared is decreasing, right? So the minimum occurs at the right endpoint, means x1, right? The second interval means 1 to 2, y equals 4 minus x squared is still decreasing, so the minimum occurs at x equals 2, right? This third interval means 2 to 3, y equals x squared minus 4 is increasing, so the minimum occurs at left endpoint, means x equals 2, x equals 2, and fourth interval means 3 to 4, y equals x squared minus 4 is still increasing, so the minimum occurs at x equals 3, right? So we have L4 of f equals f of 1 plus f of 2 plus f of 2 plus f of 3. F of 1 plus f of 2 plus f of 2 plus f of 3 times delta x, right? So f of 1, if we plug in 1 for x, is 3, right? Plus f of 2, if we plug in 2 for x, is 0, and if we plug in 2 for x, so y equals 0, so f of 1 is 3, f of 2 is 0, f of 2 is 0, and f of 3 is, if we plug in 3 for x, we have 9 minus 4 is 5. So 5 plus 0 plus 0 plus 3 is 8 times delta x. So delta x equals 1. So we have the final answer is 8. Notice that the function changes its behavior at x equals 2. We need to be very careful when picking our minimum values around this point, right? Number 2. Consider the function f of x equals x squared plus x. On the interval 0 to 2, find the numerical value of the lower Riemann sum means L4 of f. And again, first calculate the width of each subinterval means delta x equals 2 minus 0 over 4 is 1/2 or 0.5. So our subintervals are 0 to 0.5 and 0.5, and 0.5 plus 0.5 is 1, and 1 to 1.5 and 1.5 to 2. And we know that the function f of x equals x squared plus x is increasing for all of this interval, right? Since the function is always going up, the minimum value in any subinterval will always be at the left end point. Means L4 of f equals f of 0 plus f of 0.5 plus f of 1 plus f of 1.5 times delta x. So we have f of x equals x squared plus x. So L4 of f equals f of 0 is 0 plus f of 0.5 equals 0.5 squared is 0.25 plus 0.5 0.5 plus f of 1 equals 1 plus 1 2 plus f of 1.5 means 1.5 squared plus 1.5, right, times delta x times 0.5. So we have L4 of f equals 0.25 plus 0.5 equals 0.75 plus 2 plus 1.5 squared equals 2.25 plus 1.5 equals 3.75 times 0.5. So final answer is 3.25.